So when you look at something like this, you want to evaluate kind of the processes you're going to do. And so I'm going to do chain rule, obviously, because I have a group raised to the second power, right? And then I have a product rule here because I have an x times a y. Okay? And so we're going to do all of it and hopefully have enough room to do all of it. So chain rule says that I need to take the 2, multiply it in front. That's going to give me a 6. And then I'm going to have x squared plus y squared to the first power. I do not do a dy dx here because I haven't actually derived the y itself, okay? I do need to multiply that by the inside derivative, and that's where I'm going to take the derivative of the x squared and the y squared. So the derivative of x squared is just 2x. The derivative of y squared is going to be 2y dy dx. And now I have a dy dx. On the right-hand side, we're going to do the product rule. So if I take the 100x as my first and my y as my second, the derivative of 100x would just be 100 times my second, which is just y, plus the first, 100x, times the derivative of y, which is just 1 dy dx. If I were doing this, I would take a 2 out of here, right, and put it out with him. So I would have a 12. X squared plus y squared, x plus y dy dx equals 100y plus 100x dy dx. Okay, that helps me because I can actually now divide everything by 4 and have smaller numbers. I know, that's just how my brain works. You can leave it with those numbers, but you're going to be foiling and everything else with bigger numbers. And so I'm big on path of least resistance. So I would actually divide everything by a 4, right? I don't have to divide these guys because it's multiplication. I do have to divide the other side because it is addition. And so that would leave me with a 3 here, and then a 25 and a 25. And that, for me, makes my life easier. And so now, that's what we're going to do on the left-hand side. We're actually going to FOIL this. X squared times x is x cubed. X squared times y dy dx is x squared dy dx. Y squared times x is xy squared. And y squared times y dy dx is y cubed dy dx. And that equals our 25y plus 25x dy dx. I also then would distribute this 3. Okay, so I'm going to go ahead and put that 3 in here. Why? So if I were to just, it really doesn't matter how you move them. You can move them to either side. Because I have 2 dy dx's on the left-hand side here, I'm probably going to move this guy over, right? And move him over here, negative 25x dy dx. And that's going to cancel that. And then I'm going to move these over to the other side. So we're going to have a negative 3x cubed and then a negative 3xy squared on this side. And those will cancel here. And so then I would have left over here, I would have a 3x squared y with a dy dx, a 3y cubed with a dy dx, and a negative 25x with a dy dx. That's all on that side, right? On the right-hand side, I have a 25y, a negative 3x cubed, and a negative 3xy squared. Does everybody see that? And so on the left-hand side, I'm going to factor this dy dx out. And that will leave me with this 3x squared y, positive 3y cubed, and negative 25x. And on the right-hand side, I'm left with just my factors that don't have any dy dx's. And then my last step to get my derivative is to divide by this whole big group here on both sides. So my derivative is going to equal the numerator that's on the right over the denominator that I divided by from the left. All right, so if you look at the top here at the point 3, 1, So for every x, I'm going to plug in a 3. For every y, I'm going to plug in a 1. All right, and so we have negative 3 times 3 cubed minus 3 times 3 times 1 squared. All right, so we have a plus. This should be plus. So we have a plus 25 times 1. And that's still over 3 squared times 1 plus 3, 1 cubed minus 25 times 3. That's going to give me my 65 over 45. There we go. All right, so my first function is the x. My second function is the cosine of y.
I got that one.
So my product rule would be derivative of the first, which is just 1, times the second, which is cosine of... All right, so derivative of the first is 1 times the second is cosine of y, plus the first, which is just x, times the derivative of the second, which is the negative sine of y. Okay, but this is a chain rule because I have y on the inside. So it's the negative sine of y times the derivative of y, which is 1 dy dx.
Oh, wait.
And that equals 0. So if I have over here, I'll just do it over here. Derivative of cosine of y. The outside function is cosine. That's negative sine of y. The inside function is the y. So that's 1 dy dx.
Okay.
X. So I'm going to subtract the cosine of y over. I'm left with negative x sine of y dy dx equals negative cosine of y. And then I'm going to divide by my negative x sine of y, negative x sine of y. So the first part of this, dy dx, is going to equal cosine of y over x sine of y. At this point, I can plug in my 2 and pi over 3. Pi over 3 being my y, so I'm going to plug that in. The cosine of pi over 3 over 2 sine of pi over 3. Cosine, pi over 3 is a 60-degree angle, right? So it's going to be what, 1/2 and square root of 3 over 2? So it should be 1/2 over 2 square root of 3 over 2. Those cancel. So it's 1 over 2 square root of 3. That's ugly, so we're going to say square root of 3 over 6. All right, so example 7, second derivative. So second derivative is just taking it to the next derivative, which we did in the last section or so, where you take a derivative and then you take the derivative of that and then you take the derivative of that, and it's just higher order derivatives, and you can do it with implicit differentiation. So the example they give us is x squared plus y squared equals 25. This is actually a circle, right? X squared plus y squared is a circle with a radius of 5, but for implicit differentiation, you're going to do exactly what you did with the other ones. You're going to say, well, x squared, that's 2x. Y squared, that's 2y, but then I have to account for my dy dx. And then the 25, well, that's a 0. And then I am going to solve for my dy dx. I'm going to move my 2x over. And then once I have that, I can divide by my 2y. And so my dy dx ends up being just negative x over y, right? They want second derivative. So this is first derivative. So this is what would happen if I just did it once. So now I'm going to take this and do the derivative of that. Now this requires the quotient rule. So I'm going to do derivative of the top times the bottom, subtraction, and over the bottom squares. Don't forget the denominator. So derivative of the top, we'll just apply that negative there. We'll say the derivative of the top is negative 1 times the bottom, which is just y, minus the top, negative x. Derivative of the bottom is just 1 dy dx. All over the bottom squared. All right. Now what's nice about this is I actually know what dy dx is. So when I'm simplifying this, I can actually use dy dx and substitute it in. So I'm going to take that. So I'll have negative y plus x times negative x over y all over y squared. And then I can simplify this to be negative y plus, or we'll just say minus since it's a negative there, x squared over y. All over y squared. We want to get a common denominator so that we can put that y on bottom. So to get a common denominator, we're going to multiply both of these by y, which means I have negative y squared minus x squared over y squared, right? And remember, when you have a denominator over a denominator, you can just multiply those. So this ends up being negative y squared minus x squared over y cubed, okay? Then, right here, I can take a negative out. So take a negative 1 out, and that becomes a positive x squared and a positive y squared. So I'm actually going to write it like this. Well, I know what x squared plus y squared is. Right, and so now I can substitute that in, and I end up with negative 25 over y cubed. That is my second derivative there. All right, find the tangent line to the graph. Okay, so this is the same thing you did when it wasn't implicit. To find the tangent line, you have to first find the slope at that point, and then you're just going to use point slope. So you're finding the slope means you're finding the first derivative and plugging the x and y in. So first derivative of this. Now, I will say that they have it almost like you'd have to do a product rule, but don't. Just distribute. You will have to do a product rule for that one piece of it, but you won't have to do it like a group there. So if I were doing this one, I would actually distribute this guy first, the x squared, and then I would do my derivative. So I would have x to the fourth plus x squared equals y squared. And the point is the square root of 2/2. So then I would do my derivative here. So 4x cubed plus 2, this is product rule, 2xy squared plus 2x squared y dy dx equals 2y dy dx, right? And then I am going to get my dy dx's to one side, my non to the other side. So I'm just going to move this one over for ease of doing this. So 4x cubed plus 2xy squared. And then we're going to say equals 2y dy dx minus 2x squared y dy dx. So if I factor that out and then divide, my derivative is going to look like this. Dy dx equals 4x cubed plus 2xy squared divided by these guys here, 2y minus 2x squared y.
And then for the product rule, I know how to do it, like just like looking.
All right, once you get to this point, you can plug in your point if you want to, and then just go ahead and find your slope. So you can plug it in at this point. You can say 4, my x is square root of 2/2 cubed plus 2 square root of 2/2 square root of 2/2 squared all over it. They could have given us, I don't know, something without fractions, but that's okay. All right. And believe it or not, this all simplifies to 3. Right. I mean, when you do all of that, it simplifies to 3. You get here, you get 2/4. The 4's cancel, and you just get square root of 2/2. Here, you get 2, so you get 1/2, and the 2's cancel, and you end up with square root of 2/2. And then here, you get square root of 2. Here, you end up with these canceling, and so it all ends up to actually 3. I mean, that's what it all simplifies to. Once you have your slope, so you're really taking first derivative, plugging in your x and y. This is for implicit. If it were just an x, then you would just have to plug in your x value to get your slope. But find your derivative, plug in your x and y. That is your slope at that point. And then you want to do point slope. And again, they gave us a weird one for point slope, but it's going to be y minus y1 equals mx minus x1. All right, and so for this, again, use your little tricks of the trade here to get rid of your denominators before you try to add and subtract. Like, just multiply everything by 2. So, and you'll end up, if you want to, you'll end up dividing by 2. If it's already a common denominator, then just add it over and see what happens. So if I do this, this one actually works out nicely. But if it's a weird fraction, just get rid of your denominators first and worry about it. So here, this actually ends up being 3x minus 3 minus 1 is 2 square root of 2/2. Those guys cancel. So you end up with this, 3x minus the square root of 2. So really what you're doing, first derivative, plug it in. That gives you your slope. Then use point slope to find your tangent line.